Okay, I think, yes, we are now recording. Good, good. Okay, so there's our hyperbolas. They either go right, left, up, or down. And here's the thing, which one do you have? You got to find what they call the transverse axis. The transverse axis will always be the axis that has the center, the vertex, and the foci. There's the foci right there. There's the vertex. There's the center. This is called a horizontal transverse. This one would be called a what? A vertical transverse. Now, on the transverse again, you've got the center, you've got the vertex, you've got the foci. There you go. So you've got to find the transverse. The transverse is everything to you. Okay? Here we go. Let's just continue. Now this is talking about the definition of a hyperbola. What is a hyperbola? It says it's a collection of points in a plane, the difference of whose distances from two fixed points, foci, is constant. Okay, let me just draw it really quick. I'm going to draw you a hyperbola that goes left and right. Okay, there you go. I will put the center right here. I will put the vertex right here. I'll put the foci here. Okay, now, what they said to you is, on the hyperbola, if you pick a point, just pick any point, doesn't matter which point you pick, if you take the point straight to the foci, call that distance 2. This point to the other foci, call that distance 1. Okay, by definition, here it says here, the collection of all points in a plane, and it says the difference of whose distances from two fixed points stays constant. What does this mean? Subtract. So you're going to subtract the two distances. Well, I'll take the longer distance D1, and then I'll subtract the shorter distance D2, and I'm supposed to get some what? Constant value, a fixed number. Every single time you get the same number. Any guesses what that same number is? That distance, take off that distance, would equal
The distance between the foci.
between here and here. Okay. If you took that distance and then subtracted that distance off, now you're only from here to here. I don't think so. I don't think it's distance between the foci. It ends up being the distance between the vertices. It ends up being this. And you know what? How far is it from here to here? Do you know? From center, oh, you don't know, do you? You don't know this yet? I'm sorry. I thought you knew it. They do tell you guys this. From the center to the vertex is A. From the center to the other vertex is A. So how far would it be from here to here?
2A.
How far?
2A.
2A. A plus A. Sorry, that was me. So D1 minus D2 ends up being 2A. Just like this one over here. When you look over here, guys, it was equal to 2A. It's also equal to 2A here. Okay? I forgot. You didn't know that. I think that's in the next slide. It is. So what's A? And what's C? A is the distance from the center to the vertex. So if you look at this one, which I can't see very well, let me rewrite this. Here's your center. Here's your vertex. Here's your foci. Here's your other vertex. Here's your focus right there. Okay, what is A? A is the distance from the center to the vertex. So from here to here is A. What is C? Center to the focus. So from here to here is C. Now guys, isn't that the same as the ellipse? Look at the ellipse. What was the distance from the center to the vertex? A. What was the distance from the center to the foci? C. So basically it's the same thing. Same as the ellipse. I tried to write you a little note there. Nothing changed. You just have to remember what you knew last week. Okay? All right. Now, last week when it came to ellipses, we were hearing things like, where's the major axis? Where's the minor axis? It's the same thing here. Instead of the major, they don't call it major. They call it what? Transverse. Instead of saying the major axis, I'm going to say the transverse axis. So don't say major when it comes to hyperbolas. And here it is, the transverse. What will be found on the transverse? The center, the vertex, the foci, the other vertex, and the other foci. So basically everything is found on the transverse. What's this minor axis called now? It's not called minor, it's called what? Conjugate. On the conjugate axis, by the way, the conjugate axis is the perpendicular axis to the transverse. So in this case, it's vertical. Can it ever be horizontal? When would this be horizontal? Yeah, if the transverse was vertical, then the conjugate would be horizontal. Okay? All right. Anything else I want to say to you? What do we always find on the transverse? What? Vertices, center, and foci. Yep, that's it. What do you find on the conjugate? Nothing. Nothing. You just see an axis that goes perpendicular to the transverse. If the transverse is up and down, the conjugate is horizontal. Okay? All right, let's keep moving, guys. All right, what about this B value that we used to find? Remember the B value? It said go up the major, go down the major. Well, it kind of does the same thing. B is the distance on the conjugate axis. But how do you find B? Well, they tell you, go find B by doing that. But can I tell you something? When it comes to hyperbolas, the Pythagorean relationship that you are used to is now going to make sense. C squared equals A squared plus B squared. That is the Pythagorean theorem that you learned in geometry, right? Isn't that the way it was? A squared plus B squared equals C squared? Well, this is what you do to find the B value. So what they did, they solved it for B squared. They just said B squared equals C squared minus A squared. So anytime you want the B value, just use the normal Pythagorean relationship. And by the way, I'm going to grab Colton's formula sheet. On his formula sheet, I wrote that down there for you. Use C squared equals A squared plus B squared. But when it comes to ellipses, hey, does this ring a bell from last week? In the ellipse, it's A squared equals B squared plus C squared. This gets weird. Once I start putting everything together, now you got to jump back and forth. From here, that's ellipse, to here, that's hyperbolas. All right. What can I tell you here? Oh, I know. Let's pretend, just pretend we found B to be 3. Where do we go for B? From the center, where are we going to go? Here's the transverse. Where do I go, guys, if B is 3? Where? Up the conjugate. You got to go up the conjugate 3 units up and 3 units down. So if this was a 3 and this is a 3, this is where I go. That's the B value. Up 3, down 3. Okay? What's this, by the way, from here to here? How far is that? Don't tell me a number, tell me a letter.
A.
A. How far is this? A. How far is this? C. C. B. B. You got to know those are the letters and which way they tell you to go. Okay? All right. Lots of information about hyperbolas. Here we go. All right. The points. The points, A units from the center on the transverse axis and B units from the center on the conjugate axis form a what? Box. And the lines containing the diagonals of this box are asymptotes for which the graph approaches. Please watch. Look at this one. Okay. Guys, A is the distance from the center to the vertex. So from the center to the vertex is A. From the center up the conjugate is B. So I get this point, this point, this point, and down here. Now, there's a box being formed. You got to understand, up B, down B, that would be from there to there. This would be A, there's a B, there's a B, and there's an A, and there's an A. There's the box that is formed by the A and the B. Now, it also says, and the lines containing the diagonals of this box are asymptotes which the graph approaches. See this? Right through the corner of this box, through the center, through the other diagonal corner, that is an asymptote. Through this corner, through the center, through this corner, that is another asymptote. So how do you sketch your hyperbolas? You jump on the vertex, right here. You jump on the vertex and you just follow the asymptote out. Just follow it out. Follow it out and follow it out. Okay? Now, they're going to ask you to write the equation. Give me the equation of the asymptote. Oh, didn't mean to do that. Give me the equation of the asymptotes. And what they say is y equals b over ax. Why are they telling you b over a? Why is it b over a? So it's a slope. So really, what's the slope of this asymptote? Up, how far? Up b over what? Over a. Up b over a, up b over a. The slope is b over a. That's where they're coming with the b over a. Okay? How about this one right here? How about this asymptote going down? That'd be what? How far down did I go? Yeah, that's your negative b over a. Okay? So once you find the slope, you actually found both slopes. Positive b over a, negative b over a. Okay? Why are they doing this? Look. Why do they have a 0 back there? Yeah, the y-intercept. Look at the y-intercept. It crossed right at 0, 0. If you have a center of 0, 0, this is so easy to write the equation. All it's going to be is y equals slope times x. That's how easy that will be for you. What will make this harder? If it moves. If the center moves, it'll make it harder. Okay, guys. One more slide and we're off and running. Okay, this is the equation of a hyperbola. X squared over a squared minus y squared over b squared equals 1. Doesn't that look like last week's formula? Except for one thing.
Minus.
You got a minus instead of a plus. Okay, so this is the big difference right there. You got a minus in the middle. Okay? Now, your equation will have x squared first when the transverse axis is what? Horizontal. If you have a horizontal transverse axis, you will start with x squared. If I were you, I'd do this. I would just draw a picture. I'd go like this. And tell yourself, when you have a horizontal transverse axis, you will have this look. center, vertex, foci. Okay? So, when will you have y squared minus x squared? When you have a what transverse? A vertical. If you have a vertical transverse, you go with this formula. Just draw yourself another picture. Go like this. Go like this. There's your transverse right there. With the center here. Vertex here. Foci there. Okay? Do you guys notice that a squared is always positioned where? Where's the a squared? First. It's always first. And it's very important because when it's subtraction, it matters. A squared has to come first, okay? So put the a squared first on both of them. Now, see that word important? It's extremely important. The first year I taught this class, 3-4 years ago, I didn't know how important this was. Kids were getting it wrong, and it was because I just didn't emphasize this enough. Okay, what's so important? In a hyperbola equation, a is not what? Yeah, it's not always the largest. Can this a squared be smaller than b squared? Yes, it can. But wait a minute. Over here, was that true? A squared is the major axis. A squared will always be larger here than b squared. Okay, but not here. This can be either or. A squared can be bigger, a squared can be smaller. Don't worry about, oh my gosh, which one is it? Don't worry about that. Okay, it is always positive, by the way. Okay, look at this. This is a squared. That's positive x squared over a squared. This is positive y squared over a squared. A is always positive. Therefore, it must come first in the equation. All right. Guys, you can come back and read this stuff later. It will probably make more sense later. Now, let's actually start the problem. Okay? Here we go. Let's analyze and graph the hyperbola given here. Y squared over 4 minus x squared over 16 equals 1. Identify the values of a, b, c using the relationship c squared equals a squared plus b squared. Here's what you need to do every time you start a problem. Tell yourself, a is what, b is what, c is what. Okay, that 4, what do you think 4 is? Is it a, is it b, is it c? Yeah, this is really a squared. So what is a? A is 2. Okay, what's the 16, guys? It's b squared. 16 is b squared. So what's b? 4. What's c? Uh-oh. Look, see this? C squared equals a squared plus b squared. Just follow the formula out. C squared equals a squared. 4 plus b squared. 16. C squared equals 20, or better yet, what? 2 squared is 5. Okay, got it. Got it. Got it. Got it. I got my ABC. Every time you start a problem, you better know A, B, C. Okay, translate these coordinates into coordinates and put them on the coordinate graph. Not right now. You can sit in here and wait. I don't know. Okay. Okay, translate these into coordinates. Where is, what does this A value tell me? Oh, wait, sorry. Let me back you up. Can anybody tell me the center of the hyperbola? 0, 0, because it's y squared x squared. So 0, 0. Okay, got it. Here comes the toughest question of all. Is the transverse axis this way? Horizontal? Or vertical? Why are you saying vertical? Y squared is first. If y squared is first, it's a vertical transverse. This is the transverse right here. It is vertical, 0, 0. So where do I go with this A value 2? Up 2, down 2, right? Okay, there they are, vertex, vertex. Okay, what else should I do? From the center, go where? Oh, you're telling me to go, okay. You're telling me to go in the conjugate. On the transverse axis, I can go up A, down A, up C, down C. Okay, how far is this, guys? How far is 2 times square root of 5? Roughly about 4.47. Okay, so roughly 1, 2, 3, 4, 5. Right about here. Focus. Other focus. There you go. There's your vertex. There's your vertex. All right. What's this B value tell us? Now get off the transverse. Go to the conjugate axis. Go where? Right 4, left 4. Okay. Put a dot. Put a dot. These dots are not on the hyperbola. They're not on the hyperbola. They're just helping you form the box. Okay. I think I'm supposed to do this. What's the vertices? Vertices are 0, 2, and 0, negative 2. What's the foci? 0, 2 square root of 5, positive and negative, right? That's about all I can do.
How'd you get the vertices again?
Okay, I went 8,
oh, yeah,
8,
I see 2.
8. Okay, got it?
Yep.
Everybody okay with the vertices? Okay, ready? Number 3 says on the graph, on your graph, create the box that will form the asymptotes. Well, the box is formed by going from the center, up A, down A, right B, left B, okay, and that forms the box. Here comes the box, right here. Got it? Now, where do the asymptotes come from? The diagonals. Go, draw the diagonals. Go through the center. There it goes, there it goes, there it goes, and there it goes. Okay? From there, guys, a quick sketch is simple. All you do is grab the vertex, follow the asymptote out. Follow the asymptote out. There we go. There we go. I did the sketch. Sketch is done. Sketch is done. So what haven't I done? Create the box. I did it. That will form the asymptotes. Then find the equation. This is what I haven't done. Find the equation of and graph the asymptotes. I already graphed the asymptotes. I need to find the equations. So what are the equations of the asymptotes? All right, here we go. Y equals, what's the slope, guys? Can you see the slope in the box or not? Up what?
2.
Up 2. Look, up 2. This is a 2. A is 2. How far over did you go? Isn't that, yeah, that's B. That's the B value. That's 4. So you went up 2, right 4. Up 2, right 4 is?
2.
Isn't it 1/2? Rise 2, run 4. 2 over 4. What's the slope of this one, though? This line coming down. Down 2, right 4. Down 2, right 4.
Isn't it B over A then? That'll be 2.
This would be A over B. A over B.
So when it changes directions.
Oh, you look at, okay, you're going back here, aren't you? You're doing this one?
Yeah.
Okay. I didn't think I had to say this yet, but I guess I do. Here's the deal. It depends on the transverse. Which way is the transverse? On this one, the transverse was horizontal. So it was B over A. But on this one, our transverse is what? Vertical. Okay, I gotta tell you this. Do not memorize those formulas. Just look at the picture, guys. Look at the picture. It says up 2, right 4. The slope is 2/4, or 1/2. Don't think B over A over B. Just in your mind, just look at the picture. Okay? Corey, did that help what I said?
Yeah.
Okay, what's the other slope though? Wouldn't it just be negative? Down 2, right 4. Good? All right. Let's try this one. Find the equation of the hyperbola with the center 0, 0, focus 3, 0, vertex 1, 0. If I'm you, if I'm just going to write the equation, I'm going to make a quick sketch of what they just said. Here we go. Center 0, 0, focus 3, 0, vertex 1, 0. This is the center. I think most of you can see it. Can't you see it's going like this? Right? And I could put one over here, call that the vertex, call that the focus. I kind of know it goes like this. Here's my question to you right now. Tell me the transverse. Which way does the transverse go? It's what? Horizontal. All right, it's horizontal. Which would tell me it's going to be x squared first or y squared? Horizontal.
X squared.
It is x squared. Okay. So I know the equation is going to be x squared minus y squared equals 1. I got to get the a's and the b's. What's a? 1. Look, it's right here. Center to the vertex. A is 1. What's this right here? Center to the focus.
No, 3.
Yeah, but what's that letter? Yeah, you know C now. C is 3. A is 1. What's B? Now, see, here's where you have to do a little bit of work. C squared equals A squared plus B squared. C squared, 1. But what do I want here? I did that wrong, didn't I? C squared should be what? 9. A squared is 1. B squared I don't know. There. B squared is 8. If I kept going, B would be this. Okay, but we don't need B. We want what? A squared, B squared. Where's A squared go? Under the first, A squared goes under the positive part of this fraction. That's 1. What about B squared? 8. It's right here. There's the answer. That's all they wanted. Write the equation. X squared minus y squared over 8 equals 1. Good? Keep going. Will, you okay? All right. All right. Center. Not where? Not at 0, 0 anymore. Okay. All that means to you is just shift. Shift the center. Right, left, up or down. Instead of x squared, it's going to be x minus h squared. Instead of y squared, it's y minus k squared. Where, and I never wrote this for you. What's hk? What is hk? No. No, yeah. HK is the center. So if the center moves, Just put the H with the X, put the K with the Y. That's all you got to do. Now, once again, if you have a horizontal transverse axis, X comes first. If you have a vertical transverse axis, Y comes first. That's all it is. Okay, now, I got to get you to look at this. Please look. Please look, 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 look. These equations, they go with the asymptotes. Where did these equations come from? They came from point-slope form. 9th grade algebra. This right there, the slope, is really just B over A or A over B. It depends on which way the transverse goes. This number, x1, y1, that's now hk. What's hk? HK is what? The center. Remember your line went through a point? What point did your line go through? It always goes through the center. So use HK. But don't memorize these formulas. Please do not memorize them. Just understand them. They're basically point slope form. That's all it is. All right. Here we go. The center of your hyperbola has now moved. Okay? What we want to do is this. We want to find the equation for the hyperbola and draw the graph. Okay? That's what we're doing. Since we're going to draw the graph, we might as well start by sketching this thing. So what does that tell you right there?
It's a vertical transversion.
It is. It's a vertical. It's a vertical transverse axis. Which tells me what comes first? X or Y? If it's a vertical transverse, what comes first?
Why?
Y. Y comes first. It's going to be Y something squared. Okay, now, here's the deal. From this look, can you already tell me what A is? A is right here, isn't it? Isn't this A? Right? From there to there? How far up did I go? 3. Well, this has got to be from center to the foci. That's got to be what letter? Well, what letter? C. You know C. Kaylee says 5. She's right. So what don't you know? You don't know B. Okay, hang on. I got to get rid of this. I don't like all this extra drawing. Okay, so now, what's B? Follow the Pythagorean theorem, the original Pythagorean theorem that we all know. Let's see here. C squared is 25 equals 9 plus B squared. B squared equals 16. B is 4. There it is. Look at that. Get your A, B, C's right away. And then, I suppose since I'm going to sketch this thing, I'll go down 3. Call that my vertex. I'll go down 5 from the center. Call that my foci. Right? Okay. Make the box. Go make the box. The box is from the center. You got to go up A and down A. From the center, you got to go right and left 4. This is the conjugate. On the conjugate, you would go right 4, left 4. You would make a box like this. Right? There's your box. Draw the asymptotes. The asymptotes go right through the center. Corner of the box. Right through the center of the box, out the other corner. Okay? Same thing here. There you go. There's an asymptote. There's an asymptote. Then you jump on the vertex. You follow the asymptotes out. Just follow them out. Here we go. Here we go. There is my hyperbola right there. Although, you know what I haven't done? I haven't written the equation for the hyperbola. What's it going to be first?
Y minus 1 squared.
Okay, so it's y minus something squared minus x minus something squared equals 1. Corey, what is it?
Y minus 1 squared.
And then minus x minus...
It's actually x plus.
But it's minus negative 3, which makes plus 3? Okay. Is everybody okay with that? How about the a squared down here? What are we going to put? 9, because it must have been 3. Here we're putting what? 16. Are we good? Okay. You know what I'm going to ask you on the test? On the test, I'm going to ask you for this. Give me the equations for the asymptotes. What are the equations for the asymptotes? This is why I say don't memorize the formula. The only thing you should memorize in your mind is point, slope, form. You should be thinking this. That's what you should memorize. You need the slope. Go find the slope. Here we go. Come back up. From the center. Look at this line right here. Right there. What's the slope? Up how much?
3.
3. And then run how much? 4. To me, if you made the box, you made it for a reason. 3/4. What's this slope this way? Negative 3/4. Okay, so we got the slope down. It's negative 3/4. And positive 3/4. X minus, y minus. What are you going to put here and here? A point on your line. Well, what point are we going to use? The center. Why wouldn't we use the center? Look, it went right through, our lines went right through the center, here and here. So use the center point. That'd be x minus 3. Y minus 1. Guys, I'm leaving this. I'm calling that good. Period 4 said, well, should I run it through and then add 1 later? I said, if you want to, you can. I'm not going to require you to. That's good enough for me. Y minus 1 equals positive negative 3/4 x times x plus 3. You okay? Questions? All right, I'm going to ask you to do the best you can. I don't feel like I did that good of a job with this, so I feel like I'm in a haze, to be honest. I'm just kind of in my cloud talking. I don't even know if you guys can hear me. I'll be better tomorrow. I'll do a better job. Anyways, do the best you can. This is a 3-day lesson. We'll finish it up tomorrow and kind of wrap it up on Thursday. All right.